Okay, so we record on that. So you have the chapter 8 self-test assignment. And then you also have another question here about looking at the Chinook database. Include the answer to that at the bottom of your quiz questions. If folks enter it in before the class on Friday. So pretty kind of easy query, maybe. We'll look at some of this today and tomorrow. So chapter 8. It's about manipulating data. And manipulation of data deals with inserting and deleting and updating. We've already played with an insert statement. Adds a row of information to a base table or view. Cool. You can insert into, and you can optionally specify column names. You don't have to specify column names as long as you're entering values for every single column in the order that the table was created in. Typically, you should always specify column names. And then values followed by the values. Something special though with the values, one of those fields could be a subquery that you could run to pull information. And the third bullet here about specifying the columns I just already talked about. If left out, you must supply a value for each column in the table in the correct order. Most people specify the columns because they might not necessarily know how the table was created, in what order the columns were originally placed inside the table. Normal form 1, of course, states your data can only accept one value per cell, or a middle bullet here. Only one value per column is allowed. You can use some keywords, null, default, or next value for. So you can pull a sequence generator and pull a next value. And I already mentioned that the values could be a subquery, so you can use a select statement. Select statement, though, only needs to return one value. Typically, anyway, one value in the select statement. And then the last bullet there goes back up to the third bullet, that listing the columns is optional, but always recommended to put them in there. Cuts down on mistakes. Let's play with inserts. Look at a couple of examples. I'm going to go and connect to the chicken database here. I'm going to close all these other windows out I've had open. So connect to the chicken database. Let's check out what do we have in the chicken database. Do we have a manufacturer in there? Does everybody have test one? Yeah. Yay. Okay. So we have test one. Was there anything in chicken feed? No. Blank. Okay. Let's try to insert the brand ID. Let's try to insert a row in chicken feed, but instead of manually typing in the brand ID, let's see if we can query for the brand ID and use a subquery inside of an insert statement. We don't have to type in the ID for test one. We want to write a query that only returns brand ID out of the manufacturer table for the brand test one. And we do that. What would we do? Select brand ID, right? From manufacturer, then what would I put? Y'all not awake. Where? Yes. Why tab completes some things it doesn't on other. Where? Name like test one. I'll run that. No, I get a value. Let's look at making an insert statement now. So our chicken feed table. Insert into chicken feed. The feed ID is automatically generated. We don't need to specify it, but brand ID. Type. Wait. Let's put in life stage. So we'll enter those values. We'll leave the other ones blank. The PowerPoint showed we required values. The keyword. So here we had to specify the columns because we're not inserting into every single column in the table. Even if we were, it's still best to specify the columns so that we know the exact order. We can keep the values in the same order that we listed the columns in. But here, instead of putting in brand ID, I want to do something special. So type of feed. We'll put crumbles. The weight, 50. Life stage. We'll put it in as adult. So this query right down here, I can surround in parentheses, and I can go ahead and cut it out because it gives me the right brand ID of 2000. And instead of having a value up here for brand ID, I can paste in that select statement. That'd be for that value. Kind of cool. Let's see what type of errors we get when we try to run this. Well, I have a spelling error. For one. And make sure that didn't actually put anything in. So fix my spelling mistake, typo. Hen, you said? Playing hens? Oh, we had adult. You said chick? One of them? Try chick starter. Just starter. I'm gonna have to fix our constraint there. So we threw in a check constraint. All right, let's run that again. So that worked. So one of our plays with the check constraint, it worked. Our check constraint didn't let us put something in we weren't supposed to. So starter feed, layer, and all flock, was it? All life stage. So our check said, no, you're gonna screw up, put in the wrong thing. Let's go and execute the select statement. So brand ID was able to be derived from the manufacturer table. And we didn't have to go manually view the table, look at the ID number and put it in. This would be very useful for front-end applications and stuff, where that you can search for or type in the manufacturer name in the form field, and then it throws it into a select statement like this and searches for that manufacturer name and replaces the manufacturer name with an ID that's associated with it. If it doesn't exist, then you'd need to throw an error back to the user, invalid brand ID, and they'd have to fix it in the form field with that they run. But this test one right here could be, instead of variable. So if somebody's entering the information in a web form and submitting, you can automatically fill in brand ID. And because an end user is not going to have all the ID numbers memorized typically, especially on the surrogate key for all items, unless it's a really small company that has a limited number of products. Humans do better with names than strings of numbers. For some reason people don't like math. Some people anyway. Some people like math. So that made it easier to insert the data. Now, writing it the first time, that was a little complex. I could have easily looked at the couple of rows that were in the manufacturer table and typed in the 20,000 here, but I could have also made a mistake and typed in 2,000 or 200,000 instead of 20,000, and it either put in the wrong value or throw an error that it couldn't find the relation to match. So, and there's your complex insert statement. We've already done bullet 2 before. We just added in this last bullet. Values can be replaced by a select statement. Probably our most common use of a subquery in an insert is pulling out that unique ID number. Update. Well, it does what probably you'd think update would mean. It changes something. Something's already there. They're going to change something. So existing data in one or more columns and rows. To update all rows, simply use update set table column equals value. Rarely would you want to do that. Let's try that bullet. Select everything from manufacturer. We have test 1 and test 2 in manufacturer. Let's go above the select statements. And let's do an update. Table. You don't need a keyword table. Updating the table name. Update manufacturer. Set. City. To Rosebud. Go ahead and select both of them and execute. You normally don't do an update statement like that. Because probably these manufacturers are not in the same city, especially if you have manufacturers, a lot of manufacturers in this database, and be unlikely that they'd all be in the same city. And if every thing that you're ever going to put in the database is in the same city, do you need to record it that many times? So to update a single row or limited number of rows, add a where statement and the condition to limit the rows affected by the update. So we mistakenly changed the city for the first row up here, test 1 to Rosebud. It was supposed to actually stay Snowball. We only wanted the second one to be Rosebud. You can add a where. So this where is going to limit for the names test 1. It's ordered differently now on my screen. The last row modified is always the last one shown. But we didn't update both or all attributes or all the attribute city column. So avoid the simplest form of update. It's likely not what you want to do. You almost always want to add where. So I think Rosebud zip code is 72137. I think that's what I remember it being. The next part of this one, you can update numerical data by using math, such as minus, plus, multiply, and divide. Can we do that? So if we want to fix the zip code for Rosebud using math instead of just typing it in directly. I know this is not just an example. You'd want to update like pricing in the database, like sale price by 10% or raise prices by 11%. That's what's happening now. Let's use some math to subtract 513 from the zip code on manufacturer. You may want to keep some of these here for examples in your notes and stuff. So I'm going to split this out. I want to modify the one for Rosebud, which is test 2. Update my where statement. And I want to set the zip code. See if I can minus 513 from it. Round it in parentheses. Set the zip code where the zip code is subtracted from 513. Run the select statement. It should drop you down to 72137. Yeah, that's right. So do that. Update the address for test 1. Go get it updated. I used the wrong one. Test 2. Updated for test 2. Hey, that's why we're learning. Made a mistake. Now I gotta go update test 2. Updated both the same command, comma separating out the columns with one set command. So update what was test 1. Let's go ahead and fix the address, city, and name on it. Go get it. So did you update manufacturer set name equal to cool. So Stave Mill did open up in Snowball in 1912 or so. And there's some milling back in the 1930s, but they moved to Marshall probably around the 70s or something. Snowball dried up. Global warming. People moved away. Haha, that's a joke. But that it actually did move away and stuff. Okay, so back from break. So on this slide on update, we updated existing data. We covered everything. We manipulated data by using math. We used the where statement, where column ID or equals some value. And we use set to update one or more columns separated by commas. And we fixed our 2 rows in the manufacturer table with real values, corrected values. And I don't want to delete data just yet. That goes on to the next slide. I think what I want to do is look back at chapter 7 where we're selecting information. So we have just a little bit of data in 2 tables. So I do have a chicken feed table. They're linked to one of those brand IDs. And they relate to each other. The 2 tables were created in our sample database, right? We have a different number of rows though. We have how many rows in chicken feed? Really complicated. 1. How many rows do we have in manufacturer? 2. So this feed is manufactured by one company. The other company doesn't have any product associated with it. So let's pull up the type, weight, life stage, and manufacturer name. and city. And when you start to get a complex select statement designed, remember our order of operation. What is read first by the SQL implementation? What's read first? What's the order of operation? It's from, yes. So it's best to create the from before you go up and do the select. So I want to select from. In this case, I guess I'll go chicken feed. And I've got to pull stuff from multiple tables. And most people are a little bit lazy, right? Don't like to type a lot. So instead of having to use the full chicken feed all of the time, just differentiate between which column is in which table. It's best to abbreviate a table. So CF, chicken feed. And I want to join manufacturer. And I'm just going to abbreviate it with a single letter M. On, parentheses are optional, but I like to put parentheses. What column are these two tables related on? Brand ID. Yep. So we're going to link the. I also like this to be in the same order as the order that I put the tables up there. So chicken feed, then I do on chicken feed dot brand ID equals manufacturer dot brand ID. If I did not abbreviate the tables, I would have had to type chicken underscore feed dot brand ID equals manufacturer dot brand ID. And as I said, most people are just a tiny bit lazy. Coding's already enough typing as it is. Creating some abbreviations helps out. Let's look at, I wanted to look at type. Chicken feed type. Chicken feed weight. So this is where abbreviations really helping. All the times that I would have typed this out. Chicken feed, life stage, manufacturer, name. Manufacturer, let's go and pull address, manufacturer, city. Go ahead and run that. We have a Marshall Milling chick starter, crumbles, 50-pound bag. When we see the address, whether we could drive up to the mill, we'll probably get more of that. Did y'all get the same output?
For that have areas that have to be selected and
Figured it out. Okay. So we related the two tables together and pulled information out, and we have a report. This is something that you might want to create a view on. Remember, we talked about views in the past. There are a certain number of columns between two tables that have information related to each other. And because this here would make a little more, provide better information to whoever's trying to, view information about a product than looking at one table and then looking at the other table, potentially. There are more manufacturers than we have feed, right? We have 2 rows in manufacturer and only 1 row in feed. This is showing us all the rows where there's a match. It doesn't show any unmatched rows. We can add keyword in front of join. This is actually a little bit later in the book, but there is a question here in chapter 8 that gives a hint. Remember, in Canvas, there is that one question out there that I want you to pull up. And this is an example of how to query that and get that out of the Chinook database. I want to see all the manufacturers that we don't have stock in right now, and all of the stock that we have. So we have this Crumbles 50-pound starter bag. The manufacturer is typed in by me on the right side of the join statement. When you agree it's on the right side of the join, of the word join, you know your left and your right. So because I'm looking at it and it's over there on that side, I know that table has more stuff in it than chicken feed, and I want to see all of the stuff over there on that side. I can use the keyword right join. If I run this again, what do I get? I get a different output. I have 1 extra row of data provided to me, with the columns of chicken feed nulled out, unknown, because there's no match. That might help you with that bonus question in Canvas, pulling information out of the Chinook database. So we will have a chapter on multiple joins later on. if I would have typed manufacturer M join chicken feed CF, then I would have had to type in left join instead of right join because manufacturer had been on the left side of the join. It's just the order that I put the tables in depends on whether I have to use left or right. And the keyword left to right means I want to show all the rows if there's a match or not. In our case, I want to show all the manufacturer rows, whether there's a match or not. If we somehow had a chicken feed row that didn't match a manufacturer, it would not show. Change it to left instead of right. Have one row returned. So I get the same output as joining by itself because the bag of chicken feed is linked to manufacturer. There's not a row in the chicken feed table that doesn't have a manufacturer brand ID associated with it. If there was, then we would have type, weight, life stage, and then null would be under name, address, and city. If that was allowed. We don't have anything like that, so. Cool, huh? I hope that'll help you answer that question in week 7 under assignments. Let's move on with our PowerPoint. Delete. Different from drop. We've already studied that a little bit. So drop, remember, destroys the table and all rows associated with the table. Delete, on the other hand, you can remove one or more rows from a database and does not mess with the table itself. Delete from table is the exact same thing as truncate table. So why is there truncate table created if delete from table is the exact same thing as truncate table? Interesting, right? It was actually created more for the human aspect out of it. Truncate table does not have any extra code. It's just truncate table and table name semicolon. And it deletes everything from that table. One line, main purpose. Delete from table, you're supposed to have in your head, you're supposed to have delete from and where. You're never to type delete from without a where statement. If you're wanting to specifically empty out a table, and then use a separate command called truncate. Because if you're using a completely different word, it should click in your head, hey, I'm about to destroy everything, so I really want to do this if I'm using truncate. And if anytime you're using delete, you just have in your head, I have to have where there. So it's a mental reminder why they created the two different ones. Because it's dangerous. Removing stuff is always dangerous. The third bullet, you should always use where clause to limit the rows affected. Otherwise, you've removed everything. So delete from table name where some column is equal to value. Cool. So insert 3 more rows in manufacturer. For example, 3, 4, and 5. We don't care about address, city, state, or zip. Just so we have those rows in manufacturer. And then go ahead and run that select statement again that we created with joining. You should end up with 5 rows total. Most of them having, of course, null for the chicken feed attributes. Okay, you got those in there? I didn't mean. There we go, 3. I'll throw in an extra one accidentally. I ended up with 6 rows instead of 5. And you use the example in the PowerPoint to delete example 3 only. Probably when you highlighted chicken feed, you somehow highlighted the CF and replaced it with right. So we just need CF. Okay, were you able to delete example 3 only? Some of you? Some of you shaking your heads, yes. So example 3 only. Did you delete delete from manufacturer where name like example 3? Is that what you did? So if I run that, I have to make sure the upper and lowercase is correct. One more time here. So example 3 is gone. We'll get to the point where we'll show you how to make things case insensitive with data. Now, what about the second one? Can you delete example 3 and 5 at the same time? So there's 2 ways to do that one. I shouldn't have had an example 1. I should have just had an example 4 and 5. That would have been the only thing that had example 4 and 5 in it. So I could have done it like this, but I'm not going to. That would work. It was great. You remembered from last week where we talked about and or. Awesome. That right there would have got rid of 4 and 5. I couldn't have put and because there's not 2 values in a single cell. That's example 4 and 5. So we had to use or. That would work perfectly. I've also got a 1 out there I want to get rid of too. I want to get rid of all my examples. So good, you would have got bonus for that. Maybe extra for remembering what was taught in the PowerPoint and in OR. What's not been taught yet is wildcard character in SQL. It's not an asterisk, but a percent sign. So if I delete from manufacturer name like example %, that means it looks for everything that starts with example and deletes everything example with 0 or more characters after the P or after the E there. So in my case, I'm also going to kill out my mistake of example 1, plus it's going to kill off 3 and 4. Wildcard characters could be problematic, so you want to make sure when you're using wildcard characters, you actually know that you want to make sure that everything with example is being deleted, not just 3 and 4. The question did say specifically example 4 and example 5 for using an or would be probably the most correct answer with the way the question was worded up there. Can you delete everything that starts with example? Would have been using a percent sign. Again, that's the percent sign. Wildcard characters will be discussed later on in a later chapter. Sometimes it's neat to see things ahead of time. So when we actually get to the chapter, it starts making sense. So some of you may have had to go back and look at older chapters that we've covered. Things may start to make more sense if you go back and look at some of the older stuff. That's what I've always found with coding. You just got to kind of like, hey, here's a chunk of code. We'll learn a bunch of other stuff and it'll make sense later. We'll talk about it again. Pretty cool. What is our last slide? Beyond delete. Merge. We can merge tables together. Not all implementations implement merge in the same way. 2 pages show how to merge. I'm not going to have any merge in our quizzes and stuff. We're sticking with insert, update, and delete. On Wednesday, you have 1 question in Canvas. But on Wednesday, I'm going to add a few more inserting data, updates and deletes, and get some practice. And yeah, we may add a price column in for our chicken feed table. We can go back a few chapters, update a price column. And the PowerPoint covered some more math how do we increase or we change the zip code by subtracting 513. What I might look at doing is adding in some math that's a little bit more common. Maybe you need to raise the price by 11%. That's what's going on right now in the world. Inflation. You're buying less and less, or spending more and more money, or going deeper in debt. One of the two. So we'll do that on Wednesday. And we'll call it a day for Monday.